Hey there, everybody. Professor Romani again. So we'll be continuing with our lesson in Chapter 2 from your textbook Business Statistics by Lind, Marshall, and everybody else. So we looked at the example of the apartments and their list prices, and we just created some bar graphs, and we also did a pie chart before. And so far, we just focusing on what's the count and the frequencies and relative frequencies of whether they're an apartment, clubhouse, house, studio, or townhouses. Okay, so now we are trying to look at another kind of statistic, which is the list price. So if you want to be able to know like how many houses, whether apartment or townhouse, doesn't matter, how many houses are in the $300,000 price range, or how many houses are between $300,000 and $400,000, if you think that's what you could afford. How many houses are what you call in the luxury category, over $1 million. So to answer these sort of questions, you still have a lot of the data here. And if your data is kind of like unorganized, you just have a bunch of houses and their list prices. You collected it from some website. There's some bedrooms and bathrooms, some data which you might not want. But if you need to create a frequency table or relative frequency table in order for this data to be useful, right? So another way, like if you want to answer the question, like 85 observations, there's all sorts of different houses, list prices, and you would want to get some sort of meaningful summary table from all this, from 85 data points. You would want to reduce them into like 5 or 6 lines of data, and try and make them meaningful. So one way we're going to try and do this is to create this same sort of frequency table, which we did here. Okay, so I'm just going to try and copy paste that. Okay, so I don't care about these values in between, because I'm going to try and create my own values. And now we're not looking at the dwelling type, we're looking at list price instead. Okay, so we're not looking at apartments, clubhouse, studio. So these were already given to you before, but that's not what we're interested in. We are interested in some sort of like get some sort of range, $0 to $100,000, $100 to $200,000, or however you want to try and differentiate this. So a good rule of thumb as to how many classes do you have, right? Like, or what interval width do you want, right? So that's something which is given in your chapter. So this is, let's go to our presentation, and these examples are also given on page number 24, 25, and 26. So if you have the textbook, you can just go to those pages. Okay, so now we're going to try and look at constructing frequency distribution. So this is what we're going to be looking at. And so first step is construct the number of classes. And the useful recipe here is like to try and do the 2 to the power k rules. Okay, so here, if there are 42 days, then like if n is 42 and if k is 5, then 2 power 5 is 32, and 32 is less than 42. We need more than 5 classes. Okay, so if you have 6 classes, then 2 power 6 is 64, and so on and so on. Okay, so if you try and apply this rule to our observations, so how many observations do we have? We learned that there were 85 observations, so we knew that 2 power 6 is 64. So we need more than 6 classes. So 2 power 7 is definitely twice that. And so that would be more than 85. So 7 classes is something what we're looking at. Okay, so here, instead of the list price, we want some sort of like, ideally you would want 7 classes. Okay, so there's no hard rule. So this is just a recommended rule. You could even go with like 5 or 6 classes and still summarize the data effectively. Okay, so this is just a suggestion which is given on your in your PowerPoints and in your textbook. Okay, so then the next step, in some sense, is to try and determine the class or interval width. Okay, so assuming we decided to go with 7 classes, so what should be the interval of each class? It's like the maximum value minus minimum value divided by k. So here, what is our maximum value? Well, you could kind of eyeball, and this seems to be like 1.7 million. Oh, there's a 2 million over here. Seems to be the maximum value. But if you do not want to, if you have more than 85 observations and where it's harder to eyeball, just select all the observations. And what is the max value? The max value which we eyeballed is almost 2 million, and the minimum value is going to be, use the min function, select the range, and that's $56,900. So that's the cheapest shoebox, house, apartment, bachelor pad, whatever you could call it, parking space that you could find in this list of houses in Whistler, BC, and the most expensive is $2 million. So we try and use this interval width. Your interval width is going to be the max minus min, the maximum value minus the minimum value divided by 7. Okay, so roughly we try and put a comma to it. That's 277,000. So you could kind of narrow this down to a $250 or $275 or $300,000 range, right? So your first list price, like among the, you could try and keep this as $0 to $300,000. Okay, so as in, or under $300,000 if you want to try and put it. And the next one could be 300,000, 600,000. And so on. So you get the idea, and you could keep going on. It would be 600,000 to 900,000, 900,000, 1.2 million. And the last one could be over 1.8 million. Okay, so this is known as how you decided your classes, and these are the intervals. And it's important to actually make sure that the classes do not overlap. That's your next step. Set the individual class limits. So here, if you try and do like under or 100 to, this is how they're specified. Okay, so instead of 300 to 600,000, it's 300 to technically under 600,000. Okay, and then so instead of this hyphen symbol, you could just do a less than or equal to symbol. This way, classes should not overlap. You cannot have an interval which says 300 to 600,000, and the next interval be 500 to 900. That does not work because the observations tend to get repeated, and that's not useful in terms of summarizing the data. Okay, so once you have these, you could again do the same exercise which we did as before, and you could kind of get the frequencies and relative frequency. Okay, so the frequencies for this, again, you could count as count if you use the same function. This is the range. Okay, and the criteria is under $300,000. Counter function does not work. Okay, I'll figure this out later. But the final summarized values are available in table 2.7 and 2.8. Okay, so under $300,000, you have 25 listings, and 24 here, 8, 5, 11, 6, 6. And they add up to 85. And the fraction is just found the relative frequency of the fraction or the percentage, however you want to think about that. It's just that divided by 85. Okay, so 29%. And these all should add up to 1. Okay, so you can multiply them by 100 to express them in percentage, and they all add up to 100. Okay, so this is how you could create a frequency table or relative frequency table when your intervals or your interval size is not given. You create your number of classes and you kind of create your interval width, and then you could start counting and you could start tallying. Okay. So once you have this, you could start creating histograms and frequency polygons and other options. Okay. So now let's move to histogram. Histogram is again the same thing as a bar graph. It's similar to a bar chart, but here it's kind of a qualitative. Like we are not exactly counting the number of apartments or something, but we're counting something which we created. These intervals were created by us, and we're just creating a bar chart out of them, and that's pretty much known as a histogram. Okay, and the relative frequencies and the class frequencies will be useful for that, and that will be in the next video.